This is planet Earth. If we venture out into the atmosphere for a while, we'll find a group of planets around us. In the ocean around us, there are a few planets, comets, moons, and rocks. There's a small corner of the universe called our solar system, which consists of a star, the sun, around which revolves a few stellar bodies, among billions of other stars and stellar systems. All of these are located within a large spiral galaxy called the Milky Way, or the Milky Way. Alongside it are 50 to 80 other galaxies, all of which are together in a group called the local group. Together, they span an area of approximately 10 million light years. A light year is a unit of distance, not a unit of time. 1 light year is the distance light travels in 1 year. Light, as we know, travels at a speed of 300,000 kilometers per second. This massive local group is all contained within something called the Virgo Supercluster, a galaxy cluster containing a huge number of local groups spanning 110 million light years. Up until about 10 years ago, scientists believed that this galaxy cluster was the largest single cluster in the universe, with nothing larger than it. However, this isn't true. A second gigantic entity encompasses the entire cluster, and this entity has completely changed our view of the universe. In 2014, a group of researchers and astronomers gathered data on more than 8,000 galaxies surrounding our Milky Way galaxy. They mapped the location of each galaxy, determined how these galaxies were moving, and tracked their paths of motion. During their research, they noticed that certain galaxies were moving toward a specific location, while others were moving away from that location. It was as if the galaxy clusters and groups in the universe weren't randomly distributed, or that something larger was holding them together. When they mapped the paths in which the galaxies were moving, both those moving away and those approaching, they discovered a strange branching structure holding all the galaxy clusters together. They named it a supercluster, or supercluster. From this, they concluded that the supercluster is the large building block of the universe. The universe, in this sense, is similar to the neurons in the brain. Each of these neurons is an independent entity, but it branches out and connects at its ends to other neurons. This time, however, we will remove the neurons and replace them with a supercluster. The first supercluster the research team was able to map was the supercluster within which our galaxy, the Milky Way, is located. The image in front of you represents the Laniakea Supercluster, and the red dot you see is the Milky Way galaxy. When we first talk about Laniakea, you may notice that its name is a bit strange. The word Laniakea isn't English at all. It's a Hawaiian word meaning wide sky. Hawaiian was the local language spoken by the indigenous people of Hawaii before the Europeans colonized the island. As for Laniakea's specifications, this supercluster contains approximately 100,000 galaxies spread over an area of 500 million light years. Their approximate mass is estimated at about 1017 solar masses, which is the number multiplied by the mass of our sun. The Laniakea cluster is divided into 4 main branches: the Virgo Supercluster, which contains our own galaxy; the Pavo Indus cluster, the southern cluster. The Hydra Centauri cluster is considered the largest of the clusters. Together form the main branches, but in addition to these 4 clusters, there are approximately 300 to 500 subclusters, which researchers call filaments. The Laniakea cluster is surrounded by 4 other clusters, which are considered its neighbors: the Shapley Supercluster, the Buzzard cluster, the Perseus P6 cluster. The Perseus P6 extremely difficult. This was extremely difficult. Researchers initially couldn't determine the beginning and end of each supercluster. The galaxy clusters are nested in a very complex and dense network. It's a fluid world, and it's not clear which cluster belongs to which. But then they noticed something. For some reason, the supercluster pulls all the galaxies toward its center. That's why they called this center the Great Attractor. If you look at the diagram they made of Laniakea, you'll notice that its center contains a very dense concentration of galaxies. However, there are fewer galaxies at the edges. From this simple observation, they solved the puzzle. They began to look at the regions without a high galaxy density, which became the boundary separating superclusters from each other. There's something important about this Great Attractor, the center of a galaxy cluster. Space is generally characterized by 2 forces competing with each other all the time. If 2 galaxies are close together, like the Milky Way and its neighbor Andromeda, for example, gravity overcomes cosmic expansion, and the 2 galaxies begin to gravitate toward each other. This is what is actually happening right now. The Milky Way and Andromeda are expected to collide within the next few billion years. This is for small distances by astronomical standards. For larger distances, cosmic expansion wins. For example, consider the Dongolo 1 galaxy located in the constellation Cassiopeia. The distance between us is about 10 million light years. This galaxy is moving away from us, and we are also moving away. Approximately every second, we are moving away from each other by about 250 km. In other words, in the few seconds we mentioned, Our distance from each other is 1,000,000 km. So what does this have to do with the Laniakea Cluster? The Laniakea Cluster is enormous. The area it extends across in space is about 500 million light-years. What we know about physics is that an entity of this size shouldn't be able to control all the galaxies and objects scattered within its vicinity. In this case, cosmic expansion is supposed to be stronger, and these objects should continue to move away from each other. If over time, they should escape the cluster and move away from it. But that doesn't happen. The opposite is happening. The center of the cluster pulls all galaxies toward it in a very strange way. That's why researchers believe that its center contains a galactic black hole, something we've never seen before. Or perhaps a mysterious force we still don't know is capable of resisting such violent cosmic expansion. Unfortunately, to date, there's no information about what exactly resides at the center, especially since one of the Milky Way's bulges has blocked our view of the center. In the end, the universe isn't just a Laniakea cluster and the 3 or 4 clusters we mentioned. Researchers believe that this Laniakea Supercluster exists with approximately 10 million clusters, and those who are together in the visible universe that we are a part of, and that's it. Who made it this far? All of you who made it, you are the best people. Like us before you leave so we know how many of you made it to the end. And don't forget, if you have an episode suggestion, write it for us in the comments. Most of the episodes we are making now, we take from your comments.